Okay, let's make a context-free grammar for this language, which is the set of all strings a to the n, b to the m, c to the p, where n is at least m, or m is equal to p. So in other words, it is either the case that the number of a's is at least the number of b's, or, and it could be false under the second condition, the number of b's is equal to the number of c's. So we can think of this as two independent problems that are connected by or. And when that's the case, let's use union between the two subproblems. Let's solve the first one and then union the solution for the second one. So let's do the first one. I'm going to make a variable called n at least m so that we know which one we're doing. Well, that means that the number of c's here does not matter because that doesn't factor into this subproblem right here. Only the number of a's and number of b's matter. So that means we can spout off as many c's as we want. So let's go ahead and do that. What we can do is recursively call the variable a sub n at least m and spout off these c's at the very end because that's where the c's are in the string. But the base case is when we're handling just the a's and b's because, again, we can have as many c's as we want. So let's make a variable called x1. I'm going to call it x1. Well, what is this x1 variable going to do? Well, if the number of a's is at least the number of b's, then that means we need to make as many a's as b's, but have some more a's potentially. So let's make an equal number, and that's what this one is doing right here. But as the base case, we need to spout off potentially more a's. So one thing that you might try, and it does work, is something like this. The base case, the true base case, is when you have nothing left to generate, which means that we could have an equal number, but if we spouted off some more a's at the beginning, then that's good. We're allowed to make more a's. But at some point, we got to make this variable go away, and one way is with the empty string. Okay, so that handles this one. Let's handle m equals p. So similarly to this previous one, the number of a's for this case does not matter. So let's go ahead and have this variable just spit off as many a's as we want at the beginning. We need to recursively call this variable by spouting off an a at the beginning and then recursively calling it. So that will look like this. And then once we're done those, now we're focused on the number of b's and c's. And so let's transfer to a different variable called x2, which is going to do precisely that. So x2 is going to make an equal number of b's and c's. So that's very easy to do. We did something similar up here. And then the base case here, because we need it to be equal, needs to only be empty. Whereas here, we needed to generate some more a's potentially if we needed to. But we can have an equal number. Here we need to have an equal number. Okay, so we have a variable that does the first condition, another one that does the second condition. How do we combine them? With this or, which is vertical bar. So my start variable is going to be this variable, a n at least m, or this other one. So therefore, this is a context-free grammar for the set of all strings of the form a to the n, b to the m, c to the p, where n is at least m, or m equals p.